Jeremy Metzger here with ICT. Good to see you again. Step into the lab. Today we're going to talk about creating another router on a stick topology. As you remember from our previous video in this series, we created a router on a stick topology, router connected to switch, connected to PC. Well, in this video, we're going to connect two topologies together via a static route and then do a ping test to make sure everything's working properly. Let's dive in. So you can see that I have a topology dragged out already. I didn't think I needed to drag out router, switch, and PC again. And also notice that I have relabeled these devices. So here we have R1. I know there's a line through there, but you can see R1. S1 standing for switch 1, and then PC1. Over here we've got R2, S2, and PC2. Now, I got to connect these devices, pave some roads to my houses. So I'm going to click on the connections button. Actually, that didn't do it, but first of all, I'm going to drag this up here, and I'll tell you why in a minute. Now I'm going to click connections, Ethernet cable. I'm going to go to my router, click gig 01 or 00, and then click on my switch. Now, the reason I drug the router or switch out like this was because you see this drop down menu here. In the last video, apparently Gigabit Ethernet 1.1 and Gigabit Ethernet 1.2 got cut out of the recording, so you wouldn't see that. So I wanted to show you the full list of interfaces, and also because I'm going to be connecting to Gig 1.1 and I want you to see that. So there, that's connected. I'm going to select the switch, drag it back down to here, go click on my Ethernet cable, click the switch again, connect to fast Ethernet 01, and then my only option on the PC. Now, we got to give our buildings in our city addresses so that they can all communicate. So I'm going to start with the router like we did last time. Click on CLI. I'm going to go ahead and enlarge this to begin with here actually. Alright, type in no for this initial confirmation dialog. Get into my router, enable. Right, now I'm in privileged mode, from user executive mode to privileged mode, and then configure terminal to get into global configuration mode. Alright, and now I need to get into interface configuration mode. So interface gig 00, right, IP address. And this time I'm going to do it a little differently. 192.168.1.0, actually 254, right, which is the last available address within the 255.255.255.0 octet. Again, if that doesn't make sense, look for future videos. We'll have something on that. So I gave it an IP address. Now I'm going to execute a no shut to turn on the port. And there we have the confirmation. Interface gig 00 change state to up, and then the line protocol and interface gig 00 changed to up. Now I remember I talked about saving your work in the last video. Well, here I'm going to show you the difference between running configuration and startup configuration. If you remember from the last video, command to save our work was copy, run, start. Now think of it this way. In running configuration, it's like a volatile RAM on a computer. Basically, when you shut off the router, anything in running configuration is gone. It's not saved permanently. We need to transfer this to startup configuration, which is your long-term storage, your memory storage. So we're going to exit, and then exit again, back in privileged mode. And I'm going to show you something. It's called a show command, and you're going to use it a lot. Show run. All right, in here I'm going to drag this up a little bit. we have the running configuration of this router, the short-term memory. And there's going to be a bunch of different lines and sections of this that you will become familiar with later, and I'm not going to go through all of it now. Know that if you do press the enter bar one line at a time, it will register one line at a time, and if you press the space bar, it will go a block at a time. So here we can see we have internet interface, gigabit Ethernet 00, with its IP address that we just configured. You'll notice that another gigabit Ethernet 01 and one that's 02 have no IP address and they're shut down. Okay, we haven't touched these yet. Other than that, the run configuration is pretty much empty because we didn't configure anything else yet. Except I remember we actually should configure the username. I'm going to go ahead and do that now, or the host name. As I mentioned before, it's nice to know where you're at if you're SSH'd or remotely connected into various routers. So we're going to go ahead and do that. Host name, router 2 this time. Okay, now you can see that that has popped up there. All right. Now I'm going to show start. This is the configuration that your router is going to pull from when it starts and load all the commands it's going to run. So permanent storage, basically. See, the command startup config is not present. We have not saved anything yet. So if this router shuts off now, it's done. You've got to go in and reprogram everything that you did. So we're going to issue the command copy run start. So copy running configuration to startup configuration and press enter. Destination file name startup config, that is correct. So we saved our work. I'm going to exit this and go into the PC and give it an address. I'm going to click on desktop, go to IP configuration as before, put in my IP address 192.168.1.1 this time, which is the first available address. Default subnet mask is correct, so I'm going to leave it. And then my default gateway is 192.168.1.254. And exit saves it in Packet Tracer. So you remember last time, to verify that this network was correct, I pinged from the PC to the router. This time, I'm going to ping from the router to the PC. It can work both ways, and you will be doing pinging from routers a lot in your career as an IT professional or as a network engineer anyway. So I'm going to ping in privileged mode the address that I want to get to. So ping 192.168.1.1 and press enter. Okay, notice that it dropped one of the pings and that 4 were successful. Okay, this is the router basically finding the PC. It takes a minute for it to build up its ARP table, to build up its list of neighbors and who is connected to it. So that's why you see that dot there. That's normal for a first time ping. So I'm going to go ahead and exit this. So we can see that we, in addition to our previous topology, have now created another router connected to a switch connected to a PC. Will mail travel? Will communication happen between these two networks? No. We actually have to connect these two cities, if you will, with a road so that mail can travel on that road. However, you'll notice that that line's a different color. We have to use something in this case called the crossover cable. Now, computers transmit information, and routers and switches and network devices transmit information on 2 pairs of wires within an Ethernet cable. On one pair, they talk to each other. On the other pair, they listen. However, like devices don't really like to be hooked up like that. So a router to a router, a PC to a PC, because if you do hook them up like that, they're both talking on the talk pair to each other, and they're both listening on the listening pair, which means that signals are getting all jumbled up and conflicted within that first pair that they're talking to each other on, and they're listening to nothing. So we actually have to flip one termination of those wires around on one end so that they're listening and communicating on the proper pairs. That's why we call it a crossover cable. So let's do that. Back in Packet Tracer, I'm going to go down to my connections menu and select this copper crossover cable. I'm going to left click it, come up to the router here, and I'm going to select Gigabit Ethernet 01 to Gigabit Ethernet 01. That doesn't really matter for this. And now they're connected. As you'll notice, however, both ports are shut and they don't have an address, so we got to get in there and program these just like we did the other ones for our router on a stick topologies. So I'm going to enable config T interface gig, and this was 01. All right, IP address. I'll go ahead and drag this out. IP address 1, no, actually, this time I'm going to do 10.10.10.10. Okay, a totally different network. And I'm going to keep the subnet mask the same. All right, press enter, no shut. And it says that interface gig 01 has changed state to up. Okay, exit, exit, and copy, run, start. I'm going to go over here to the next router and do the same thing. I'm going to enter global configuration mode, and then interface gig, 01, IP address 10.10.10.11 this time, right, with the same subnet mask to keep things simple. No shut. And you'll notice now in the previous router only this first one had popped up, this first notification, interface gigabit Ethernet, whatever it is, change state to up. This says that line protocol on interface gigabit Ethernet 01 change state to up. That means it's connected on both ends and ready to communicate. Going to exit, exit, and I'm going to test this with a ping. Ping 10.10.10.10, which is gig 01 on R1, and click enter. Again, it had to find its neighbor first, but after that, the communication was successful. So now we're going to copy, run, start. Great. So we have connected both cities, okay, with a road. Now, can communication happen yet? Well, it might look like it because PC1 is connected to the same router that R2 is connected to. But this can't happen quite yet. Think of it like this. We've got the city that PC1 and R1 live in, okay, and then we've got a separate city that PC2 and R2 live in. And they do have a road connecting them. But think of the interface, gig 00 as a post office. So gig 00 on R1 is the post office for PC1. If PC1 wants to send mail to R2, it's not going to get there because that post office doesn't know where to send it yet. Okay, there's a road nearby, but the post office doesn't know where the road is necessarily. It doesn't know that that's the direction it needs to go. So think about it this way. A router is like a mail processing facility. It literally processes communication and then sends it out in the directions that that communication needs to go. So we need to create a processing facility in R1 so that R1 knows, hey, if I'm going to get to a destination address, a destination city that PC2 lives in, I got to go to the next processing facility, right? And likewise, we're going to create a processing facility within R2 to do the same thing. If I'm going to get to PC1 and R1 city, I got to go to the next mail processing facility. So let's do that. I'm going to go over here and click on R1. I'll start here like I did in the previous video. Okay, and for this I need to get into global configuration mode. So config terminal. All right, and then I'm going to type in this command, IP route. IP route it'll be 192.168.1.0 with the 255.255.255.0 subnet mask. And then I'm going to put in the address 10.10.10.11. Now, here's what we're doing with this. IP route is going to tell the router, I'm creating a standard defined route that mail needs to travel on. Okay? And then with 192.168.1.0.255.255.255.0, what does that remind you of? This is the same network that we created over here with the R2 and then down to the switch into the PC. This is the PC2 network, the destination. Okay, so we're saying, hey, if you want to get to this destination, you have to go to this address, which is gig01 of R2. All right, so we're creating a standard route to a specific destination city and a specific destination processing facility. So I'm going to click enter, and that's all. As always, I'm going to exit and copy run start to save my work. I'm going to exit, and this time we're going to do something very similar here. Config terminal to get into global configuration mode. IP route, because I'm creating this processing facility command, so to speak. And then destination network or city 192.168.0.0 with the 255.255.255.0 subnet mask. Go to this processing facility 10.10.10.10. Okay, I'm going to click enter, exit, and then copy, run, start. So we've paved the road between the networks. We've given processing facilities for each end so that now mail can be routed anywhere it needs to go. Now we're going to do a ping test like we did with actually both networks in the previous video and in this one, but this time to verify that the entire highway network and mail delivery system that we just created is working properly. So first of all, we're going to ping from PC1 to gig00 on R1, right, to our post office. So it's going to look like this. PC1 is going to send a signal through the switch to the post office, and the post office is going to go, hey, got mail, I'm going to respond. So let's do that. Here in PC1, I'm going to click command prompt and I'm going to ping 192.168.0.254. And we've got a reply. Next, we're going to ping from PC1 all the way to R1 and see our static route work. It's going to look like this. PC1 is going to send a signal to the post office. The processing facility is going to go, hey, that's that way. The next processing facility is going to send it back down through the post office, through the switch to the PC. Let's see that on Packet Tracer. I'm going to get back into command prompt and ping 10.10.10.11 and see the response. It worked. Now, we're going to ping all the way from PC1 to PC2 and see this thing work through and through. So it's going to look like this. PC1 will send a signal to its post office, which will send it through the static route across the highway down to PC2. PC2 is going to respond with mail to his post office. That'll send it through the processing facility to the next processing facility back down to the sending address. In Packet Tracer, we're going to ping 192.168.1.1 and we get a reply. We're also going to ping from R2, okay, to PC1 just to verify that both directions work, because it is good. Your job is not done until both directions work. I've been in situations where I've been troubleshooting and I can ping one way and some applications are not working on my computer or on my router, and I realize that communication actually isn't coming back. So to do the job thoroughly, we're going to go ahead and ping from R1 to PC1. So ping 192.168.0.1 and it is successful. Okay, in this video we have set up another static route in addition to the one that we created in the previous video. We connected them with a highway. We created processing facilities within the routers so that the routers know where to send mail, and then we verified that the whole system is working well. Make sure to check out our website for more videos, check out my LinkedIn page, and our Facebook page. Thank you very much for watching, and I'll see you in the next video.